diagrams. Force diagrams are going to become something that you know, love, and can draw. Again, 2 a.m., shaken awake. Why are you waking me up? So there are 2 different kinds of diagrams that are discussed in your book. The force diagram is the one that we will work the most with. The other is a free body we'll work with the free body diagram. So a force diagram, that's right, shows every single force in a situation. So I want you to imagine for a second the seat that you're sitting in, all the forces that are acting on you. So name me one force that's acting on you. Gravity, pick the easy one. Name me another force, the low-hanging fruit is gone. Not so much.
For me it is.
Oh, but you know what? Actually.
Yeah, this is a magnet and there's a magnet inside.
Yes, but it is a balanced force, however. It's not.
It's still force.
Pain in my tuchus. Okay. That was good. That was good. Okay. So we've got the center of the earth is pulling down on you. For some of us, we have magnets in our heads. Not all of us. What are some other forces acting on you? So the center of the earth is pulling down on you. Anything else happening? Nothing else happened.
Doesn't your mass have force?
Well, that's the center of the earth. So yes, the more mass you have, the more attractive you are to the center of the earth. So, okay, the weight of the atmosphere is pushing down on you, which is again, center of the earth attracting all of the air around you, pushing down on you. What else? So you're all floating, levitating in the air, your butts are not touching anything? Okay. Cool. That's a neat trick. Okay, the chair is pushing up on your butt. For some of you, the back of the chair, some of you are not sitting against the back of the chair, but for some of you, the back of the chair is exerting a force against you as you exert a force against it. We're starting to get into a pretty good list of forces, aren't we? If we do an actual full-on force diagram, we will show every single force acting on you. It sounds terrible, yes. So what we do is actually called a free body diagram. We pick a single object, we diagram the forces acting on that object, and we isolate it. So we kind of pretend that something is sitting out here in space with just these 4 things acting on it, or these 3 things acting on it. We don't show everything, and that simplifies life tremendously. Stephen mentioned a good one. He said, "Isn't the air exerting some sort of force on us?" Oh yes, yes. You will get accustomed to the phrase in physics, disregarding fill in the blank, disregarding air resistance, disregarding friction, disregarding blah blah blah, disregarding blah blah blah. Very often at this level of physics, we ignore air, which is really nice. Trust me, you want to ignore air. It makes things much simpler. When we talked about projectile motion, you might recall that we said, in the absence of air resistance, the path of a projectile, exactly, a frictionless vacuum. And I will pull up at some point, maybe it's in here? No, it's not. Oh, there it is. There we go. So we do a lot of problems in a frictionless vacuum. This is pretty common in physics. What happened? Where am I? How? Someone... Huh. Looks like physics professors don't like working in frictionless vacuums after all. They are such liars. So now let's get back to free body diagrams. So we are going to there we go. We're going to practice some free body diagrams. What? That he's in a frictionless vacuum?
He's floating.
Heck, I feel like I'm floating some mornings before I finish my second cup of coffee. Okay. We're going to pause this.